Good afternoon, good morning, good evening, depending on where you are today. Today we're going to be talking about uh, wellness, employee wellness, and absenteeism in a corporate setting. So it's just imaginative scenario that is very, very likely to happen if you work as a data analyst or as a consultant. Is that the HR director will come to you and say, we have these people who are absent because of due to health issues, for instance. How can we try to incentivize the people who have good habits and try to get a better understanding of absenteeism and its causes? This is when you as data analyst can step in um, I mean, fascinating enough, this is very, very close to scenarios where I've had working in international organization where an HR manager would come in, step in and say we want to do this sort of analysis. So it's going to be very exciting, and I hope you will enjoy it. Of course, it's a beautiful Friday here in Helsinki, in Tampere, Finland, and I hope you all will have a great weekend. Okay, so let's dive right into it. First, as always, I would appreciate your support completely. Please, if you kind of enjoy this video, please do go ahead, like and subscribe. Visit my LinkedIn, visit my website. Your support is always very much appreciated. Okay, so today we'll be talking about taking data analytics and trying to sort of utilize it for something that would actually make a difference in employees' lives. So, what is our problem context, or what is the statement here that we're trying to address? We have an HR director who calls us, and she tells us, we need a consultation for the employee data that we have on the health, wellness, and absenteeism. She is asking you to do three things. First is to compile a list of the healthiest individuals and with low absenteeism for a healthy bonus program. And the second is they have a bit of a budget for wage increases and annual compensations for non-smokers, which both of these things would be incentivizing people to stay healthy and actually attract smokers to become non-smokers. And lastly, she's asking you to create a dashboard for HR itself to understand absenteeism at work and also to monitor it, of course. So she has the raw data inputs for you. She has a budget of $1,000 for the healthy bonus program, and finally she has the information that the insurance budget non-smokers is 983 to 121 dollars, which basically means you have this amount of money to sort of distribute as an annual compensation or an annual incentive for non-smokers. And of course, there is an agreed upon wireframe that you need to stick to while you are developing your dashboard. So these are the steps that we are going to take in creating this project, or in doing this project. We're going to be building a database. That's first and foremost. We're going to develop the SQL query that is needed. We're going to do the analysis in SQL, and then we're going to connect to Power BI to sort of data visualize and really develop a good dashboard for HR to get a better understanding of absenteeism the different variables that we have. And the wireframe that we're going to stick to is this one here. A wireframe is basically like an agreed upon initial design of the database, how you think it's going to look like. And this is, of course, this particular wireframe was proposed by Absent Data. Please, he's a very, very incredible source for knowledge as well. Pay his channel a visit and show your support. So we will not get into the deliverables. I think it's better off. We're better off to seeing like step by step how we got the results and move on to the dashboard and design, and from there we can kind of think through how we actually achieve these results. So first steps first, or first things first, we're gonna connect to the SQL server. Of course, this server is now on my local machine because I'm on my personal laptop. So I'm gonna connect here, look at my database. So of course, the first step would be creating the database called, I called it employee health, for example. And then into that, you go to tasks, you go to import flat file because we have like three different CSVs that are flat. And then on that basis, you just continue with the process until it leads you to have three tables. We will have the table called absenteeism at work. We will have the one called compensation, and we will have reasons. So let me just open this file where I have actually kind of already did the query. Okay, so here's our query. In this particular point, we're just joining all these the three different tables that we have. And afterwards, we're trying to create a group of the healthiest employees, right? So this is kind of like a pseudocode, more or less, is we're trying to find the healthiest employees to give the $1,000 USD total bonus, for instance. We first start by thinking as data analysts, what are our criteria? For us, we thought, okay, so the person should not be a social smoker, and they should. I'm just opening this so you have an idea of the columns that we have in the absenteeism. So social smoker is one and zero, like basically binary. Either a person is, either they're not, or they're not. And social drinker is the same. The body mass we index here we have is basically a number on the BMI that the data came with. They provided it. We did not calculate it. But off of Google, quick Google, tells me that less than 25 is healthy. So basically, what we would like is to create a new table and call it healthiest employees, right? And this table will be selecting everything from absenteeism at work, where we had already kind of joined the compensation part and joined the reasons table. And what we want to do is to insert the entries in healthiest employees, this table, where the social drinker, whether the person is not a social drinker, the person and using and to sort of exclude anything else, and not a social smoker, and that their body mass index is less than 25. And here it gets a bit tricky, but it's rather like understandable, is that you would like their absenteeism time in hours to be less than the average absenteeism time in hours of the entire sample. Okay, so from absenteeism. So once we've ran this query and we have the healthiest employees table, we have it now with these criteria, and we can just take a quick look at it. Okay, so we have 111 um, entries, so 111 employees that apply, or the criteria applies to them. So these are the first, that answers the first question of, there's $1,000. We want to distribute it as a bonus for people who are healthy. We developed the criteria. Turns out there's 111, so it's like 9 point something, I guess, or 8 point something. per each employee dollar, which means, they can get a meal off of the cafeteria. Maybe they can give them a couple of drinks, coupons, or maybe a small knickknack to sort of commemorate that they are the healthiest and least absent employees. So, well, then we move on to the compensation part, increase for non-smokers of an annual budget with, an annual budget of 983 to 121 USD. So, what we do first is we select the count of non-smokers as non-smokers from the table called absenteeism at work, where the social smoker indicator is 0. We have basically the result is 686 non-smoker employees, and we have a salary increase budget, a total of 984,221 USD. And then from our head, we consider an 8-hour business day. We work 5 days a week and 52 weeks a year. So we kind of, it's much better to create a CTA here using with and as. So with total hours as, select and do this simple arithmetic as total number of hours per year. So now we have the total number of hours, like working hours per year. We should do this calculation. Let me just we will let me run this query and start. Okay, so running this only this part of the query is this simple arithmetic would return to us about 1,400,000 something hours per year, working hours per year for all the 686 employees. So the step after that is we would like to calculate how that translates into an per hour increase in salary for non-smokers. So we take this budget that we have right here, which is I'm not sure if sometimes it says 983, sometimes 84. So I'm just gonna leave it as is because it reflects into the Power BI, and I'm honestly too lazy to kind of go and fix it. So let's leave it as is, and then we do this calculation. We take the number and then we cast this total number of hours per year, whatever the total is, as decimal, and that gives us a salary increase per hour. And of course, using the table, the CTE that we created, total hours. I will run this and let's see what happens. Okay, so we do have 0.689 more or less, which is then perfect for us. Now let's optimize the query that we are actually gonna take and go connect to Power BI with it from using this database. So it looks like a bit of a complex query, but if you sort of chop it up into parts, then it becomes a lot easier. So first for starters, we would like to have this, our main table is absenteeism as work. I will label it as A, and we will join to it the compensation table that we saw as B, and then A has a column called absenteeism at work, has a column called ID. B has a column called ID. We want to join them based on on the equivalency of those two columns. And then we will join also reasons C. A has a reason for absence column, which is a number, and C has a number identifier. So we'll join these two tables based on this supposedly equivalent column as well. And then we need to think through what other tables are we gonna use for our Power BI dashboard? Thinking through it, we have here the columns, which is helpful to get a bit of an idea over which ones might be interesting for us. We have the ID, which you're gonna grab from A, this column. We have the reason, the particular reason, actually, from table C, which is reason, the table called reason. This is like a description for the number, the number that we can find in the absenteeism at work table. We also have the month of absence, which is fine, the body mass index as a figure, all good and well. And now we would like to do two things before moving into Power BI. It's just like a bit simpler here. Is using case one. It's basically similar to an if conditional. Case one, we want to do create a variable called season name. We would like, if the month of absence is 1, 2, or 12, then we would like it to be winter. If it's 3, 4, 5, then spring, 6, 7, 8, summer, and the rest fall. Otherwise, unknown. Give me an unknown, please. And then the same thing we have the values of the BMI, but we'd like to categorize them into underweight, healthy weight, overweight, and obese. So using these operatives between and bigger than, smaller than. Basically, again, this like how this particular measure, I just grabbed the information off of Google. What are the ranges and so on. And then we would like also to see the day of the week where absenteeism happens. How much does it happen per each day? The transportation expense, because we also could look at whether it factors into the decision to be absent. The education, the number of sons, I think, or daughters in this particular scenario, whether the person is social or a social drinker or smoker, a number of pets, whether that person has had a disciplinary failure, the age, workload average, and finally, of course, the absenteeism time and hours. So, as I said, if you just take a look at it, it might look a bit complex, but actually, it's a very useful and easy query if you chop it up into what you want to do, sort of like a pseudocode, as we call it, in programming. So this is our dashboard that we have developed basically for HR to get a better understanding of absenteeism and wellness. If you remember, looks a lot similar to the wireframe that we had agreed upon with HR. We had one KPI, main KPI, which was the average of absenteeism time in hours per employee, which makes sense. And then we have a number of employees as number of entries that we have 740. We have 5,120,000 hours of absenteeism. We distributed the 740 employees into social smokers and social drinkers, whether or not they are social smokers, whether or not they're social drinkers. And we also distributed them by the count of body mass index and the category. So if we want to take a look at only the healthy individual, we will look at healthy weight. The BMI starts from 19 to 25, very reasonable. 12% are high smokers. Surprisingly, the main KPI for absenteeism is higher than the average of the population. And we also gave them a number of absenteeism trends, especially by, as agreed, they're both like a kind of a timeline. One is by month of the year, where it really pops up is, in month three, so that'd be March, and in July. So March and July, we have the highest uh, total number of absenteeism. And actually, per the day of the week, people prefer to take the second day off. That would be Sunday, Monday. We will say Monday, Tuesday, Wednesday, Thursday, and Friday. So we'll say people prefer to take Monday off, or the total. Well, we can't say that. We can say that the total absenteeism is highest on Mondays. Of course, here we give them the option to filter by any particular season. So let's see which one is the highest season where people, well, it's summer, the summer. People really kind of like to take their days off in the summer. And another thing that we have done is to look at the relationships. That's last part of the dashboard is really what comes to mind, as good indicators to take a look at. How, if you were in the HR shoes, what would you like to look at? I think that transportation cost is a very intriguing variable. Does indeed, like when transportation costs increase, does average absenteeism increase as well? So we see in this, like given this chart, it's not really true. We have like a more of a horizontal linear relationship between two. It does not seem to be like effective in one way or the other, but that also can be attributed to this outlier. This is a very high outlier in terms of average absenteeism. So I'm thinking about what happens if we exclude it here. Well, we excluded that the relationship turns a bit positive. Although more, we can do more analysis on this. The results are not super clear, but one cannot argue in favor of that the transportation costs is really the problem with the average, at least given the entire population. The HR people are free to pick if they want to use whichever filters that we have provided for them. Are we talking about smokers? Are we talking about drinkers, or none of those? Are we talking about people who smoke but don't drink? What category of BMI, and so on and so forth. And then finally, the last thing that felt reasonable to include is the reason, the actual reason or the description of the reason why this absent employee was absent, and it is basically a frequency of how often we got that reason. The other column is a frequency of how often we get that reason, and by of course a large margin, medical consultations and dental consultations are the highest two reasons for absence. Um, we can, of course, the power of the best thing about Power BI is you really get to narrow down and zoom in on particular people. One of the interesting results I've seen is that if you look at social smokers, you will find that the average of absenteeism is 6.5 actually. And then if you look at social drinkers, you'll find that the KPI is 7.68. So it's intriguing. Of course, we cannot like make a direct relationship, as in like causing X causes Y, that simply without taking other variables into account. But nonetheless, I think it's a very interesting result that deserves some deeper insights and deep. As always, a big thank you for joining me on this data analysis journey. I realized that the projects have been in different industries. I think that's part of why it's very important is to be very flexible in dealing with data, how to design dashboards that satisfy stakeholders in different industries and also of different levels. Um, Please, you're welcome to find this presentation video and more on my YouTube channel um, listed here. And also, please feel free to visit my website. As always, happy analyzing.